So this is my progress on the Ruby on Rails assignment so far. So this right over here is my Ruby on Rails IDE and it's JetBrains IDE. These are all of the files which are required. This is the Docker file for this application, and just so you know, this Ruby on Rails application also uses Redis for caching, ELK stack for the logging management, and for monitoring it uses Datadog. So for the logging, I'm using the Logstash, which will be sending the data to Elasticsearch, and Elasticsearch will be giving data to Kibana, and Kibana will be helping us visualize the data and monitor the logs. So this is my application files right over here. This is the app and all. So these are the files. This is the Docker Compose file for the ELK. As you can see, Kibana, Logstash, Elasticsearch. This is my Logstash configuration file, which is this. And this is my Datadog installation logging file. It's not needed. And this is also my gem file, which is configured for the Datadog also. And this is my Ruby on Rails log files, this and this. These are all of my log files, as you can see. Now I already have the application running. I'll just run it in right now again. So now this right over here should be running. This is my Rails app. See, it's running right now. It's listening on the localhost port 3000. Now I'll just open this real quick. So as you can see, this is my Ruby on Rails application. Now essentially you can add any number to a database. Let's say I add number 1 to the database, then this database is PostgreSQL, and I can check if this number is in the database. And as you can see, it says the number existing from database. If I try to check it again, it's gonna get it from the Redis cache, and it's gonna say the number 1 exists in the database. Let's say I put a random number and I can check if it's in the database. As you can see, this does not exist in the database. I can also add it, but now if I were to check it again, it's gonna say it's still not present because it is getting from the cache, and the cache will expire in about 1 minute. So after 1 minute, if we check it again, it will be getting it from the database, and it will be telling that this number exists in the database. So this is my Kibana. It's getting all the logs. I'll just show it to you. Refreshing. So these are all the logs, and I can see any visualizations or anything of that sort. Let's say I want to see a visualization of the methods. Click on visualize. I can see how many requests and get and post requests are coming, and I can see this as a graphs. And let's say for status method, so how many records are okay, how many are found, what are these and these. This is not that important. Timestamp of when the requests are coming. I can use this to analyze what is the most popular time for the application to be visited, so I know when the peak timing will be coming. This is also the active record. This isn't that important either. controller action. You can also see the top 5 values of these. The host name, the parameters, etc. So we can see all of the messages and everything about what's happening to the application. We can visualize it. So that's essentially the use of this Kibana over here, and I'll just show it to you real quick. I'm running this in Docker. So this first of all is my Datadog agent. It's for the monitoring. This second one is for Kibana. This one is for Elasticsearch. This one is for the Logstash. So Logstash is essentially ingesting the log files. It's sending to Elasticsearch, and Kibana is visualizing these logs. So now that we have seen the Elasticsearch and all of its the ELK stack stuff, I'll also be quickly showing that this number will now come from the database. As you can see, it's coming from the database, and now it's cached again. So it's cached. Now I'll also be seeing the metrics of the Elasticsearch to see how it's right now, what's the status of it now. As you can see, I can see all the metrics of the Elasticsearch: the query latency, query index, the indexing time, the index memory size, the nodes, which is currently only one. I did not add many nodes. The shards also, I haven't added too many. And system load, and this is very important so that we can see if our servers are having any bottlenecks. This IO for the Elasticsearch Docker container. System memory, it's taking a constant of about 12 gigabytes, which is a lot. And network traffic, this isn't that important right now because we are debugging any network bottleneck. And this one is the overview of the Elasticsearch. It's going to see how much disk space it has used, how much of the storage size is taken, and it's going to be telling the nodes the highest activity. It's giving all of this visualization, documents the indexing latency, the most indexing activity, and network summary, the HTTP traffic, and also and this is very useful so we can see if any bottleneck is occurring. The shards, 11 shards, unassigned shards, logs, active shards, initializing shards, unassigned shards. This is for Elasticsearch. This one is for my CPU, like what's the CPU of the server, like is the server having too many tasks to do. So we can see this, and we can also see the overall system metrics like CPU usage. Currently it's 100%, the IO weight, system load, system memory, network traffic, and then we can also see the disks monitoring, that we will be knowing if there is any sort of like bottleneck happening when we are doing the write operations, like especially for the database, because in the database the write operations are important. So we can see the CRUD if any issues are being faced. As you can see, no bottlenecks are occurring. You can see the write rate, disk CPU, disk write, disk read, disk latency, IO weight. This we can mainly use to see the bottlenecks. Now this one is for the containers, like as you know the ELK stack and of Redis is running in the container. Now it's telling all of the CPU core load for ELK. This is the memory, this is the byte by image. Now it's telling all of the intensive containers, like which container is taking a lot of resources, if any resources are tabbed too much. So as you can see, Logstash is having the highest CPU usage, and Elasticsearch is having the least CPU usage. And then we're also seeing the cache memory. This is for the Datadog agent, so this isn't important, but this and this is very important. And now we can see the TX intensive containers. Now we also see another graph for the CPU by container. Now we see the most RAM intensive, And as you can see, Elasticsearch is taking the most amount of memory over our application, as you can see, and tx by container another graph, and memory by container. This is also very important so we can analyze any performance issues. Now this one is the Ruby runtime metrics, which I will be configuring soon. So that's it for this recording, and the step 1 of the assignment is done. The Ruby on Rails application I have created by writing a little code. So the Ruby on Rails application is created. I have created its Docker file also. So the application is Dockerized, and the Redis, which I am using for caching, is also in Docker container. 1 second, it's here. So this Redis is also Dockerized. It is running in another server. Now this is my Redis container, and I'm also having the Postgres Dockerized. So this is also in another container, and it's also having the signed ports, so any issues will not be happening. So all of that has been Dockerized, and all of it's running. The monitoring, logging, the database, caching, everything is working for now. And now I'll be proceeding with the step 2, is which is to do all of this in Kubernetes, and essentially we just be deploying the Ruby on Rails application with the caching on Kubernetes for the simplicity. Thank you.